Have you ever looked outside an airplane window during a storm and wondered what would happen if lightning suddenly hit the aircraft? Because here's the terrifying part. A single lightning bolt can reach temperatures hotter than the surface of the sun, carry hundreds of millions of volts, and travel faster than your brain can even process. Now imagine that striking a metal airplane flying at 35,000 feet, with hundreds of passengers inside. Shouldn't the aircraft instantly explode? Shouldn't every electronic system fail? And how are pilots not blinded every time this happens? Because yes, airplanes are actually struck by lightning surprisingly often. And by the end of this video, you'll understand exactly why modern aircraft can survive it, and the hidden engineering tricks protecting everyone on board. Welcome to Airspace Academy. Every second, around 5,000 airplanes are flying somewhere above Earth, and many of them are crossing giant thunder clouds filled with electrical energy powerful enough to light entire cities. A typical lightning strike can contain up to 300 million volts. That's enough energy to destroy buildings, melt metal, and instantly kill a human. Yet commercial aircraft are designed to survive direct hits multiple times during their lifetime. In fact, statistically, most commercial airplanes get struck by lightning at least once every year. But here's where it gets interesting. The reason airplanes survive lightning is not because they avoid electricity. It's because engineers actually want the electricity to pass through the airplane. That sounds completely backwards, and to understand why, we need to go back decades. In the early days of aviation, lightning strikes were far more dangerous. Older aircraft used less conductive materials, weaker electronics, and minimal shielding. Some planes even caught fire after strikes because fuel vapors ignited inside the tanks. That forced aerospace engineers to completely rethink aircraft design. And eventually, they discovered something fascinating. If electricity can smoothly flow across the outside surface of an aircraft without entering sensitive systems, the airplane can survive almost unharmed. Think of it like water flowing around a rock in a river. The smoother the path, the less damage happens. And that idea became the foundation of modern lightning protection systems. Now imagine this. You're sitting inside a passenger jet during a storm. Suddenly, flash, a lightning bolt hits the nose of the aircraft. For a split second, the entire airplane becomes part of the lightning's path. The electricity enters from one point, usually the nose, wingtip, or tail, then races across the outer metal skin of the aircraft, and this happens insanely fast. The current then exits from another point, often the tail, so technically, the airplane gets hit and survives in the same moment. But that's not the full story, because modern airplanes are not just giant chunks of metal anymore. Many newer aircraft, like the Boeing 787 Dreamliner, use lightweight carbon fiber composite materials instead of traditional aluminum. And carbon composites don't conduct electricity nearly as well as metal, which created a huge new engineering problem. How do you safely guide lightning through a material that resists electrical flow? The solution is something most passengers never notice. Engineers embed thin layers of conductive metal mesh underneath the aircraft's skin. So when lightning strikes, the electricity still gets a controlled path to travel safely around the airplane. This is the part nobody talks about. The biggest danger is often not the lightning itself, it's the electronics. Modern aircraft are filled with flight computers, navigation systems, radar equipment, sensors, communication systems, and fly-by-wire controls. A powerful lightning strike can generate massive electromagnetic pulses. Think of it like a giant, invisible shockwave attacking the airplane's nervous system. So engineers shield critical electronics using grounding systems, protective layers, surge protection devices, and specially designed wiring routes. Even the fuel tanks receive special protection, because one tiny spark inside a fuel tank could be catastrophic. That's why fuel systems are heavily insulated and carefully grounded. But here's something even crazier. Airplanes are intentionally tested for lightning strikes before entering service, not with real storms, but with giant lightning simulators. Engineers literally fire artificial lightning at aircraft sections to see what breaks. Some tests produce sparks so powerful they look like science fiction weapons. And every critical component must prove it can survive. Now you might wonder, what do passengers actually experience during a real strike? Usually, almost nothing. Most people only notice a bright flash and maybe a loud bang. Pilots are trained for it. Aircraft systems are designed for it, and planes continue flying normally afterward in most cases. But occasionally, minor damage still happens. Small burn marks can appear near entry or exit points. Tiny holes may form on wing edges. Sometimes, sensors temporarily fail and need replacement after landing. That's why aircraft are carefully inspected after suspected lightning strikes. And here's a detail most people don't know. Those little static wicks sticking out from airplane wings and tails, they help safely discharge built-up electrical energy into the atmosphere. They look tiny and unimportant, but they play a major role in controlling electrical behavior around the aircraft. Another surprising detail: aircraft radomes, the nose cones hiding weather radar systems, are specially designed to handle lightning without destroying the sensitive radar equipment inside. Even airplane windows are engineered carefully. The outer layers include conductive coatings that help dissipate electrical energy safely. Every part of the aircraft is designed with lightning in mind, because at cruising altitude, lightning is not considered a rare emergency. It's considered an engineering reality. And when you zoom out, it's honestly incredible. Humans built a machine weighing hundreds of tons, filled it with people, sent it through violent storms at near the speed of sound, and designed it so electricity hotter than the sun can strike it midair, without bringing it down. That's the hidden brilliance of aerospace engineering. Lightning doesn't simply miss airplanes. Engineers learned how to control where the energy flows, and once you understand that, the entire system suddenly makes perfect sense. But thunderstorms hide even more aviation mysteries, because sometimes pilots avoid clouds that look completely harmless, while flying directly through others that look terrifying. The world of flying machines is full of secrets, and in the next episode, we're revealing another one. Subscribe to Airspace Academy, and I'll see you in the next one.